Are we good? All right.
All right, so we're live now. Malima, I can see some people here on. Here we go again by Kunle Obasoro. I can see you. Yusuf. Wow, that's good having you here. Fantastic. So Malima is supposed to assist me with moderating. Good. We have. Oh, nice. It says fresh year. Good. Welcome, guys. So I'm going to go backstage and leave Malima to do some introductions. Last week we had a lot of issues with me presenting and moderating at the same time. So I have my man here to assist us with that. That I believe is going to do a great job. So I'll go backstage and he's going to call me back in again, and then we'll kick off with the hands-on session. All right.
Okay. If you can hear me, you can thumb up so that I will believe I'm not speaking to myself. If you can hear me, let me get a thumb up. Okay. Nice. Thank you. Welcome to today's section where we will be diving in. Okay. Sorry. I'm coming. Okay, where we'll be diving into building the cheapest Kubernetes, right? So, in today's workshop, Ukeme David will be taking the stage. Ukeme David will be taking the stage, and okay, to give a little background about who Ukeme is. Ukeme is a software engineer, a cloud and a DevOps engineer with in the blockchain, right? So what do I mean? So if you have been wondering whether we have DevOps cloud engineers in the blockchain space, so Ukeme David is one of the engineer you have met with one today. So he is also a AWS community builder who specializes in cloud infrastructure, automation, and blockchain node operation. He has worked with leading Web3 companies such as Supra, Oracle, Alpha Day, and Nethermind, and driving innovation at the intersection of DevOps and blockchain technology. So Ukeme has built several micros software as a service product, including Tiny Paizo, a media compressed platform, and also he has built Mockup Wiz, an AI native platform that enable users to create mockup in a second. So without wasting much of time, I will bring in Ukeme to the stage. Yes, thank you, Ukeme. Have the stage.
Okay, thank you so much for that introduction, Malima. Malima is going to be backstage in case there's any issues to assist with anything going on. So this is going to be a very, very interesting session. I promise you that. And I believe not everybody here in this session is a pro DevOps engineer. So there are people of different levels, and I'm just going to be very accommodating to the lower levels of engineers. Well, not lower level, beginners, intermediate, and also advanced engineers. Altogether, we would work on this. So when I go a bit low in terms of what I'm explaining, don't get too upset because I need to carry everybody along. So I'm going to share my screen real quickly and let me do that. Yep. So this is what we're talking about today. We're talking about building the cheapest Kubernetes cluster. Can you guys see my screen? Yeah. Building the cheapest Kubernetes cluster on AWS EC2. So this is not we are not saying an EKS, as an elastic Kubernetes cluster, or AKS, any other Kubernetes cluster you create. We're not saying those are not good. We're not saying they are dead. We're saying there's a cheaper way to do these things, right? Because if you try to spin up an EKS cluster on AWS, it's going to cost you a lot of money. I think you're looking at $1,000 per month, or if not more than that. Um, and you just want to spin up a home environment where you can practice, test whatever you're doing in Kubernetes, and you want to be able to spin it up, pause it, and then share. Like, you don't need a cluster running 247, right? So this is actually for you, right? So what exactly is Kubernetes, right? So Kubernetes is actually a container orchestration tool or a platform. Container orchestration, what does this mean? So when we there's a kind of architecture we use, which is called dockerizing your architecture, your application, right? You want to deploy an app, and the architecture that is very popular at the moment, we're not saying is very is the main thing, but it's very popular at the moment, is containerization, right? You want to containerize your application, and to do that you need Docker. And last week we talked about Docker, and we were able to deploy a Next.js application to App Runner. So it's pretty much almost the same thing, right? The same concept in terms of containerization, creating a Docker image and all of that. But this time, while we are orchestrating multiple containers. That's what Kubernetes is actually used for. To orchestrate multiple containers, microservices, pretty much advanced stuff. So we're like, okay, why don't we dumb this down a bit and just create the same environment but on an EC2? What is an EC2, right? An EC2 is short for AWS Elastic Compute, Cloud Compute, right? It's a virtual machine. I'm sure you know what a virtual machine is. So it's a virtual machine. So we are saying this multiple container orchestration environment, can we press everything down and compress it into an EC2 instance, right? And that is what we are going to do today. This is going to be a lot of interesting stuff. So let's get to it. So the first thing we are going to do traditionally is you need to have an AWS account to follow up with this. I'm just gonna sign up or sign in. Sorry, you need to have an AWS account. So with this now, you'll be spending something around $50 per month. You might not even spend up to $50 per month, right? Because it's an EC2, you can spin it up, do whatever you want to do, and stop it. And then the only thing you might be paying for is storage, and storage is very, very cheap because you don't need so much storage, right? So I actually wrote an article here. Malima, please, can you put this article in the chat box? I wrote the link to this article. I wrote this article, and that's what we're going to use. Just so in case I'm too fast or in case of anything, you can always follow up with the steps in this article, right? So the article is saying, first thing, the prerequisites we need is actually to have an EC2 instance running an Amazon Linux OS, right? AMI per se. And then just make sure you have your key pair to connect to that. So that's what I'll be doing. Step one, I'm just going to log into my AWS. It's good to have MFA installed in your AWS. Always have MFA for security. 956. Yep. So we're in. I am just going to open an EC2 instance. You can come here to search for EC2 for those who don't know what it is, but for advanced engineers, you already know what this is already. And we would create a virtual machine, right? So to create a virtual machine, just click on instances here. I already have this already set up, so I'm just going to create another one. I'm just going to, on the top right corner, you see launch instances, click on that. And then let's call this cheap K8. Cheap, you can name it anything, cheap K8 cluster, right? And in terms of the OS, we want this virtual machine to run on Amazon Amazon Linux 2023. That's what we're using by default. Leave all of this by default. And there's the instance type, right? So if you're following up, I would suggest we use something that has like a 4 gig RAM, right? 4 or 8 gig RAM, because we are trying to cut costs. T2 medium. Should we use a T2 medium or should we use a T? Let's use a T2 large, just because we don't want to have any issues where the entire virtual machine might be hanging because of too much of load, right? So a T2 large has a 2 vCPUs and 8 gig of memory of RAM. You can experiment with a T2 medium with 4 gig of RAM, but for this, I'm just going to use this. The idea is I should be able to spin it up, do whatever I want to do, and pause it or stop the instance so it doesn't accumulate more cost. So the next thing is to create your key pair. For those who don't know what the key pair is kind of like a key you use to access the machine. I'm just going to call this chipk8 key, right? And then just create key pair. This should download to my local machine. Good. So in terms of networking, we can just leave it as it is, create the security group and just leave it as it is. In terms of storage, let's put a 20 gigabytes of storage. This should be enough. Eventually, you just be paying for storage while your machine is idle. Right. So let's create our machine. Great. So we have our machine as it is. Oops. I just leave it as it is. Give me a second. Okay, so we have our machine. The next thing is to SSH into that machine using our key pair. So I have 2 terminals here. I'm thinking which one I should use. I have Tabby and I have WAP. So I'm going to use WAP. So with WAP, I can ls. You need to know some Linux to do this. I can ls to see if our key pair is actually here. I believe it is here already. It's actually downloaded to my. Okay, this is it here. For some reason, this is what it gave me. So I'm just going to rename this. Just call it chip K8 key. No, chip K8 is okay. Okay, so the next thing now is to SSH into the machine. And before we SSH, we need to give this machine the permissions to connect. So we'll do chmod plus chmod 400. We need to give this key permissions to connect, and then the name is chipk8 chipk8.perm. So this file actually has that permission. If we do an ls-la chipk8, you should see it has only write permission. So we're trying to restrict connection. So the next thing now is to connect to the machine. And if you click on connect here, you should be able to see a shortcut to doing this. Hold on. Yeah, so this is a shortcut to doing it. You can just copy this and then do that. But I don't advise people to do this because you won't learn. So the best way to learn is to write the command yourself. So ssh-i is the command, and then you reference your key chipk8.perm, and then as you can see here, the user is called ec2 user. You have to use that user. You're using ec2-user at the IP address, right? You can also use, where is that? You can use this to connect. It's public DNS, but I prefer to use the IP address, this IP address, in which you can also find that same IP address here. The public IP address is what we're connecting to. So if you do this, you say yes. Great. So we're in that machine now, right? We're in that machine, present working directory. We can see EC2 user. Great. So the next thing now is to check our steps. So we've SSH into the machine. Malima, please, have you shared that link? Okay, the link is actually there. Thank you. Great, 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 great. So the next thing now is to install Docker, right? So we're using a containerized way to set up this thing, this pseudo Kubernetes cluster in an EC2 instance. So we need to install Docker. But before we do that, we need to update, right? So the package manager for Amazon Linux 2 is actually DNF. But if you are running it on Ubuntu, you do a sudo apt update or something, right? But we are using a sudo DNF updates because we are running Amazon Linux 2, right? So DNF is kind of like the package manager. So we're just updating everything in the system. Okay, great. This should take a few seconds. Good. So dependencies resolved, nothing to complete. Next thing is to install Docker. I've done this before. See, I advise people to use WAP. WAP, that's what it's called. Is an intelligence terminal. You don't want to miss out on most of these things. So just go to WAP. I think it's search for WAP here. We can share this in the chat. So in case you don't have WAP, you can use any terminal anyways. But I like using WAP because it's very intelligent. Yeah. So we need to install Docker. It's already telling me to do a sudo DNF Docker because I've done it before and it has memories of what I'm trying to do. Yep, so that is going to install Docker. You can see these are the dependencies it needs. IP table libs, container D. Give me a minute. I need to snap this thing for my publicity sake. Yes. So container D and all that. You just click on yes, and then it's going to install that for you. So we wait for that to complete. Yes. So container D and all that. So just click on yes, and then it's going to install that for you. So we're just waiting for that to complete. In the interim, I'm also checking on my end to see how the live stream is doing. Great. So we have Docker installed. We have Docker installed, and the next thing is to start your Docker and enable it, right? If you follow this here, you'll see all of that there. So let me just run you through the command. So sudo systemctl start Docker. So systemctl actually means system control, and then we're starting the Docker we've installed. So if I do that, I can do a Docker version. So we see Docker is installed. Now we want to be very sure that these are started. So how we do that is to do a sudo systemctl again status. So Docker. So you use status to actually check the state of your the service running. As you can see, is the Docker the service. This is the systemd service running, right? So now one other thing we need to do is to enable
Sorry, we
Docker.
can't see your screen. You're not sharing.
Exactly. Thank you so much. So
Thank you.
this is the reason why I needed Malima. Because sometimes my laptop will just decide not to share. Like he has his own mind. Okay. Okay, I see that. I'm sure you can see my screen now.
Yes, yes, we can see your screen.
Okay, good. So I stopped at sudo systemctl status, right? So this is what you use to check the status of your of the systemd service running, right? So now we need to enable Docker. Why do we need to enable Docker? It's just so that when you stop your EC2 instance, right? When you stop your machine, if I come here and I click stop so that I don't acquire cost, if I stop the machine, anytime I start it again, I need Docker to automatically start without me trying to type the command systemctl start Docker, right? It needs to automatically start. So that's why we need to enable Docker. So we will do that sudo systemctl start enable Docker. Great. So Docker is enabled, and that is the result. The next step now is to, we've done all of that. Yes. So the next step now is to give Docker, right, user, create a Docker user and then create, like give it that group permissions, right? So that's what this is doing, the user modification, right, for Docker to this user. And you just copy this and paste it there, right? You can see the command is also in the blog post. You can copy that there too. And then create this new group, apply the changes to the Docker group, right? So we're just doing that. Yep. So we can now see that we've done that. And then the next thing is check Docker version. I've already done this before. We've done this before, but if you want to do it again, you can do it. Yeah. So you see the Docker version, the engine, and everything. Next step is something called kind. So, no, sorry, kubectl. We'll still install kind, but let's install kubectl. So what kubectl is, or kubectl is what some people call it. Kubectl is kind of like a command line interface used to interact with Kubernetes cluster, right? So the same way we are doing sudo this, sudo that, it's also, we'll be using kubectl as a CLI tool. That's a command line interface tool to interact with the Kubernetes cluster we would create on this machine. So that's what kubectl is. Professionals, most of you guys already know it, but if you don't, you can just search for kubectl and then you would see stuff about it. Yep. And you can also check on how you can install it and everything. But I already have that written here, so there's no need for you to, look for the link. It's already here in the chat. And this is not something you cram. You can't cram this URL, right? So what you do is copy and paste, actually. So let's not try to sound too smart. All right. So I'll just copy and paste that. This is going to download the kubectl binary using a call request. What is going on? Yeah, so we have that. For some of you, it might not be this fast because I have some very good internet. Law. Next thing is this is optional, but you need to download the kubectl checksum file. This is just going to validate the binary you've downloaded, right? So I'm just gonna do that. Seems I've stopped sharing again. Have I stopped sharing? Malima. Okay, I'm still
Oh,
sharing.
you are sharing. Your screen is up. We're good.
Okay. Okay. Thank you. All right. So I copy this. I paste it there. Validates. Yes. So that's the .sha file, and then validate the kubectl binary against the checksum. So what it did was we downloaded two files. We downloaded the binary and we downloaded the SHA file, which is to validate. But now we need to use both of them. Like we need to use both of them. So what we do is just to copy this, and then it's going to verify. We should be seeing something like OK there. Kubectl is what OK. All right. So we have that running. Now we need to install kubectl, right? So what we did was to download the binary, validate the binary. Now this is the command to actually install it. You don't have to cram all these things. Just copy and paste as far as you know what it is doing. knowledge is more important, right? So that was fast. Kubectl has been installed. You can use this to check the version. So you see the client version 1.34.2, and then the customized version also. To get more details, you use this command. We have to output it as a YAML file, the client, right? So you see that kubectl version client dash dash output in the YAML format. That's what this is saying. And we have that here. So if you want to see more details about the version of what is installed, you have that there. Great. So now we are using kind. Kind is where the magic comes in. I said I won't be doing any magic, but it sounds like magic. Kind is where the magic comes in. Kind is actually called Kubernetes in Docker. Remember, we installed Docker initially. So Kubernetes in Docker is what we'll be using to simulate that Kubernetes cluster. Even though we will still create the control plane and all of that, but we have to install this, right? If you want to know more about kind, go online and just do your kind Kubernetes K8, and it's going to, you can see this. You can read more about kind here. We've already done 30 minutes here, so I don't want to go into the details, but kind actually means Kubernetes in Docker, right? So let's install kind. Yep, for AMD machines, which what we're doing, just copy this. I can explain what it is also. We are copying, oops, that's not what we need. Cancel that, clear the screen. This is what we need. Yep. Aha, so what's this doing? We get this user, and then we get the machine architecture, which is what we have here. And meaning we're stringing two commands together. We make a call request. A call request is basically when you want to hit an HTTPS endpoint. That's when you use a call request to download a file or retrieve a file from the internet, right? And this is the URL to download the kind for AMD64. And then the next line is chmod plus x dot slash kind, meaning when we download this, we're getting this dot slash kind file, and then we are making this file an executable. That's what the chmod plus x command is doing. And then we move this file, sudo move this file from dot slash kind to this particular directory here, right? I hope you're not confused, but you can just copy and paste. I'm just trying to explain for those who want to know the details. All right, so that is installed and all the strings of 4 commands have been executed. This file now is actually an executable. If you want to see it, you can come here and do a cd. Oops, I don't want to do a cd. ls that directory path, and you can see that file there, right? That folder actually is a folder. Great. So kind is installed. Want to check the version? Just copy this and put it here. You can see the kind version there. This is just to confirm that kind has been installed. Kubernetes in Docker. Now this is the juicy part. So what we are trying to do now is to set up a Kubernetes control plane. So it's going to be a 3-node cluster, right? It's a 3-node cluster, and we'll be running this command very soon. But I just want to show you this is the code that actually does the magic, right? So we're using kind, right? This is a YAML file, Kubernetes manifest file, and the kind of that file is called a cluster. And then we want to create several nodes. We want to create 3 major nodes, right? So the control plane is the first node we're creating, and then all of this is basically for networking, right? Because you are creating pods. You want to be able to simulate pods. Now in Kubernetes, the smallest unit, how do I put it? That's how they used to say it. What is a pod in Kubernetes? I think they say it's the smallest abstracted unit in Kubernetes is called a pod. Yeah. So it's kind of like in Docker is a container. It's a container, but in Kubernetes, they make it a pod. So that's just your application running in a specific environment. So think about for those who don't know what Kubernetes is, because it's not everybody that is on the same level here. Think about I'll stop sharing again.
can see, yeah, your screen. Just check.
Uh, Thanks, Malima. Yep. Malima, where did I stop? Like, where did I stop?
No,
I hope I didn't go far gone.
yeah.
I
So
didn't
you
go too
were
far.
no, you haven't. You haven't. Can you hear
Okay.
me?
Yes,
Yes.
I can.
Yeah. So it was in this explanation that your screen decided to just take it as an excuse. So yeah,
Okay.
you are good.
All right. Yes. So, yep. So control planes and then pods, right? We're talking about pods, and these pods we need to create some kind of like networking on how, because with Kubernetes you're orchestrating multiple containers, right? Meaning if you have 5 containers, all these 5 containers should be able to communicate to each other. There needs to be a port open for them to communicate. So that's what this is actually doing. We're actually just opening ports for a container port, this the host port, and then is listening on 0.0.0, meaning anybody, any it's just open, right? So we have to do that, and then the protocol obviously is TCP protocol, and then we create a worker. With this worker, we are opening port 8080, we are opening port 8000, we are opening port 8080, 8081, and then we have just one more role called a worker. So we have 2 workers and 1 cluster. That's why we called it a 3 node cluster, right? This is where the magic is. So we're going to create this file, nano 3 node cluster, and basically just copy and paste. All right. So copy and paste. Coops, coops, posh. Yep. So if I do an ls now, I can see that file, 3 node cluster. I do a cat 3 node cluster, and you can see everything there. So that file is there. Now, I already did all this explanation already. So the next thing now is to create the kind cluster. So because we have installed kind before, kind is now a a command we can call. So if I say kind, oops, this is blocking. If I just say kind, we can verify that kind is actually here. So we're doing kind create cluster with this config using this file. That's what this is just saying. Use kind to create a cluster with a config, and this file is the config. Just gonna copy and paste that. So that's gonna get set up. That's gonna get set up. I'm just gonna check my other social media accounts to see if I'm getting any messages there. Um, hmm, getting a lot of messages from the WhatsApp group. I'm sorry, I can't reply to the WhatsApp group. uh, I can't reply to the WhatsApp group. I'm live, so please, you can continue conversations there. I'll come back to that. But let's see what's happening in the studio while we wait for that to. Studio looks good. Well done. Great, 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 great. Uh, yep. I'll screenshot this for my social media engagement also. Yeah. So we see ensuring node image, preparing nodes, writing the configuration, starting control plane, installing the CLI. It's just a lot of things. If you know Kubernetes, this should be easy for you. But for those who don't know Kubernetes, just leave it as it is. All right, leave it as it is. And as you grow in the game, you begin to understand most of all these components that are being used. That's how I learned, to be honest. Yeah, so the next thing, the command we need is actually this, but we can still copy it from here. Now you want to get the cluster information. All right, you want to get cluster information. Now we can literally use the kubectl we downloaded initially, right? So we're doing kubectl cluster information context. The context is this kind. You use context to switch between clusters or get details of a cluster, right? It's just to check that we have a cluster installed. Yep. So we have the control plane is running on localhost, and this is the ports and the namespaces, kube system services, DNS, everything is just this is just where core DNS is actually running. All right. So we have our cluster. So in this case, I can bravely tell you that we have done this already. We have created the Kubernetes cluster, but it still doesn't make sense if we don't try to use it, right? We need to use it at least for something. So we're going to install something we can use to. I can bravely tell you
Your
that
screen.
we have done this already. We have created the Kubernetes cluster, but it still doesn't make sense if we don't try to
Can you hear me? Your screen.
it,
So
right?
I
Yeah.
am watching on the YouTube.
We're going to install something we can use. This case, I can. Okay, thank you. Bravely tell you that screen. All right. All right. Thank you. So there was a feedback there, but I really appreciate that. Yup. So we need to use this cluster, right? Right now, maybe from next week, we can have a session where we will start installing applications or creating microservices architecture applications on this cluster. But for now, we are just doing basic stuff, right? Nothing too advanced, right? So you can now start using the kubectl commands to get whatever is happening there. So kubectl get nodes. You can see we have our 3 cluster nodes there, 2 worker nodes and 1 control plane. You can do a kubectl get namespace. So these are Kubernetes commands, right? And if you check kubectl tools, you can see all this command here. Once you get advanced, you would understand some of these things I'm saying. Or maybe next week we can continue if people want to know more about Kubernetes for those who do not know. Um, yeah, get namespace. You can see the namespaces here. Kubectl get pods dash a. So this is getting all the pods running. As you can see, everything is actually working in this cluster. So what I promised you is what we've already done. What I promised you is what we've done. You can see Q proxy is running, scheduler is running, etc, core DNS, everything is running. There's no errors there. So what's the next thing? I said I was going to install a visualizer, right? Which is a very cool thing. So we need to set up a visualizer so we can see the nodes in action, how they are working, that kind of thing. And we're using kubeops view. Kubeops view. You can check the GitHub repo. Kubeops view. These are all open source stuff. Yep. Is this it? I think they moved it. I think they moved it, but this is it anyways. Yep. This is it. This is it. This is what we are going to. You see how cool this is. Trust me. Trust me. This is cool. This is super, super cool. Let's not deceive ourselves. So, creating visualizations of the pods and everything running. This is how to actually install it, but I already have a simpler way here. Here. So what we're going to do is to clone this repo. I hope this works. So because now that I've seen that they've moved it, okay, I already cloned it to my own personal repo. So what we need to do now is to get GitHub, right? We need to get Git, right? We need to install Git so we can clone the repo, this repo. Malima should put this in the chat, please. Yeah, so I actually cloned the repo before they moved it. So everything is here in my right. Um, Malima, please put that in the chat. If that's possible. Well, let me just put it there myself. Oh, you said okay, you will do that. Okay. Um, so you just need to copy this and then put this in the chat. So, anyways, we want to install Git. So because we are using Amazon Linux 2, that's why we're using the DNF as our package manager. All right. So I'm just going to install this. So sudo DNF install Git. Right. These are the dependencies. And we say yes, it's just 41 megabytes. That is installed. That is installed. So now we can clone the repo. So git clone, I'm sure you know git clone already. So we just clone that repo. Great, 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 great. So if we do an ls now, we can see the kubeops view folder. We can cd into that kubeops view folder. Cd ls, and we have all the files here we need, right? So moving on, that's the command here to cd. We now need to deploy, right? We are deploying the develop folder, right? So kubectl apply dash deploy folder, right? Deploy folder, my bad. So this is the deploy folder here. We can actually check what is actually there. We can do an ls deploy folder. And we have a couple of things here. Let me just clear my screen so it doesn't confuse anybody. Okay. So we have a couple of files here. We have the auth file, the auth manifest. We have the deployment manifest, the ingress, and the service. Next time we can go deep into all of this, but I don't think we have that time around. We are already 45 minutes past the time. I'll be in the time. So we will just kubectl apply. So it's basically going to deploy all the files there. So it has created everything. You can see created a service account, created a cluster role, RBAC, created a role binding, created the deployment, created the ingress, created the service. All these things are like fundamental building blocks in Kubernetes. And once you start learning Kubernetes, you understand how everything like works together and what it means in the greater like the holistic view of container orchestration. All right, all right, all right. So we can do kubectl get pods, and we should see we have kubeops view running. Okay, that's good. So we are 90% done. The next thing now is to set up security groups, right? Why do we need to set up security groups? Because in AWS, we won't be able to access this. We won't be able to access it if we don't exclusively allow this port. So kubeops view is actually listening on port 32,000, right? And we need to allow this port so that traffic can come in through that, and we'll be able to view, um, have a visualization of how our cluster, the pods and the cluster is working, right? So we go back to our AWS here. This is the node I created initially. This one, right? So we'll go there, and then we're going to security, and then security, see the security group here. And then we need to edit the inbound rules, right? I hope I'm not fast. The inbound rules, you had a new rule. And in this rule, we're allowing port 32,000, the TCP, right? We're allowing port 32,000 in 0.0.0 anywhere. Nope, but let's do my IP. So it's going to be constrained to just my machine. If you do the same, it's going to constrain to just your machine. And then we allow that. Good. Once we allow that, now it means we can actually visualize what we have here. All right. So what I'm going to do is I'm going to get my IP address. I'll go back to the EC2 instance. Go back to this. Get this IP address. Open a new tab. And if I do this, nothing is going to happen. This should not work, right? It won't work because we need to add this there. So we're saying the IP address in port 32,000 because that's what we open, and then you add this command to scale 2.0, right? So this is just the scale 2.0 is just like, okay, this is the value of how big we want it to look. So I'm just going to append that to the IP address. Where's the IP address? Let me just do this. To make things easier, just going to copy this here, come here, add it in front. So it's one line, copy it again. Open a new tab, and that is it. This should work. If it doesn't work, then there's a problem somewhere. Voila. So we can see what is going on, bro. Bro. This is cool, bro. So we see our control plane here. The control plane, we can see kube proxy. This is kube proxy. This is kube scheduler. The cool thing about it, you can see the pods in action. If I install something now using Helm or whatever, we would see that pod in action, and we can see the CPU usage. That's the cool thing about it. You can see the CPU usage, you can see the memory being used. You don't have to start going through the terminal to see what's going on. You can visually see it. So that brings me to the end of today. Is there any other thing? Yeah. So I have a conclusion written here. What did I even write? As our adventure draws to a close, blah 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 blah. Look, look, we've done this, and that's pretty much it. If you have any questions, let's see those questions in the chat. Thank you.
Yes, thank you, Ukeme, for a nice presentation. Thank you. And this is now time for question. The audience from the YouTube, the audience from the LinkedIn, you can send in your question so we can answer it together. Yes. Yeah.
So
Uh,
we're just waiting for questions now. Put your questions in the chat. If there's no question, then it means everybody here is a pro.
it's a
And
pro.
yes, and you're not my target audience. Because I should not be talking to pros. You already know all these things. Questions. Put the questions in the chat. We have just a few minutes.
Wow. So that
No
means today
questions.
you are working with the pros. Only me that I'm here.
Ah, that's crazy. Oh. It's either I'm working with pros or they were just outstanding with the presentation. So you can clap if you're outstanding. I'm just joking, anyways.
Yeah.
Thank you. I'll clap for myself too. All right, so we have 2 more minutes for questions. And we call it a day.
Yeah.
Oh, Malima, is there anything you want to say about the entire thing?
No.
What do you want to
Okay.
say?
Okay. Oh, all right. So somebody is asking a question here. So can you see the question?
Yeah, put it on screen. Okay.
Okay. So he said, at what stage of my application should I switch to Kubernetes instead of just plain Docker?
This is a very good question. It shows that you're following. So, you switch to Kubernetes when you start doing microservices, right? So, for example, you have a three-tier application, right? You have your front end, your back end, one tier. You also have your database. You also, maybe your database is also running front end, back end. You have your database. Maybe your database is running on PostgreSQL. You also have your um, Redis. You're using the Redis cache. When you have so many microservices, it can run on Docker, right? But if you want to simulate it in your local machine, you can use Docker Compose. Docker Compose is close to that, but it doesn't properly orchestrate like Kubernetes, because Kubernetes is kind of like an OS, cloud native OS. When you start handling networking, you're handling ingress, you're handling so many other components. I mean, Docker can't just do that for you. You have to go to Kubernetes. I'll give you an example. Netflix uses a microservice architecture. There are many companies that use it, but I'm just saying Netflix, for example. And they have a microservice for signing in. They have a microservice for showing the video. They have a microservice for buy for payments. They have a micro. So the reason why they are doing that is because it doesn't become a monolithic application anymore. Meaning, if something fails for a monolithic application, everything is going to go down. But with microservice, if search is not working, you should still be able to watch a movie.
Yeah.
Do you get? If the movie playing is not working, you should still be able to see all the list of all the movies. So once you get more advanced, you have to get to Kubernetes. I hope that answers your question.
Okay, John, I believe your questions has been answered correctly. And if you have more questions, you can share them up before we call it a day.
All right, all right, all right, all right, all right. Questions. So it's only John now that can ask question. Now, wow.
Eh,
Eh, okay, okay, Malima, let's close. Let's just call it a day.
all right,
Um,
thank you for today. Yeah, and hope to be somebody like you too. One day I will present it also.
yeah, yeah, sure. Come on now. Come on, you present. You've been presenting since now. You were at the Web3 Lagos, so please don't do that. Don't do that. But Malima, is there anything you want to say about today's session? Like, what do you think about it in general?
Okay, so for me, the presentation is okay for me. Even though I've been playing around with uh, Google Clouds related. So
Services.
to me, it's just like okay, it's almost the same thing because all the
Yeah.
all those things are just same thing for me. The speed and everything are on point. Is not that fast, but I don't know. I don't want to speak for others, but yeah, we for today is top notch, and we can do better.
Okay, great, 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 great. All right, so that'll be the end of today's stream. We would keep in touch. You can send me a DM, check my LinkedIn or my YouTube if you want to reach out to me for anything. So till next week, do have a